Hello.
Okay, now we'll start with demo. We'll start two demo. First one is your sine wave, and we'll see in analog output. And here, first one is your sine wave. We'll see in analog out, and at that time of execution, we'll change that amplitude using constant value in console part. And here is DSO is not available. Same sine wave, we'll take it through analog in, and we'll see in our scope. And the second one is our, we have need to design one inverter. And this is our PWM. We'll get PWM out from D out.
Sir, your screen is not visible.
Sir, your screen is not
Okay. Yeah, now is visible.
Yes, sir.
Yes, sir.
Okay, first one is our sine wave. We'll see sine wave in analog out, but here is DSO is not available. Then same sine wave, we'll take loop back and we'll see in our scope. And the second one is your, we have need to design single phase inverter, and this is your PWM generate. We'll get it PWM from digital out, and we'll give this digital out to inverter. So that means is it your digital in, and we'll see this result analog out. Okay, let's start. Okay, first what the procedure? We have to first design our model based on Simulink. After that, we have need to design our model using OPAL library. Okay, this is the simple model. Whenever I will increase this constant value, and according to that, this constant value is multiply with your sine wave, and you will get same result. So first we have need to make two subsystem. One is master. In master, I'm taking this sine wave and this product. And this is your master, this is your console. That master name should be like SM ABC, whatever you want, any name. SC, XJ. After naming, we have need to change our solver. Go to model, model setting. Type fixed step, and it should be like OD4. According to it's depend on your model. So fixed step type step size is 10e minus 6. Then outcome block should be placed always after input. See, data is coming from SM to SC, then outcome block we have need to place in SC. Data is coming from SC to SM, outcome block we have need to place in SM here after input. See, same one outcome block here, it will showing your sampling time, and if we placed in mass console, it's showing acquisition. This outcome block total number of input is 25. If your input is exceed than 25, then you have need to use another one outcome. And here is your acquisition number 1. Then you can use it acquisition number 2. Okay.
Like this, how many acquisitions we can use, sir?
I'm not sure. Actually, you can go up to 256 like that type of. I'm not sure.
Okay.
Okay. So then power GUI. Now this model is ready for software synchronization mode. First we have need to save this model. Yeah, now your model is saved. First we have need to close it. Then open RTLab. Create a new project. That project name is OPJU sign. Next, empty, finish. Next is import your model. Desktop, this sign one. Your model is imported. Previously, we have added this model, demo model. Okay, after that, we'll see this demo model. Then I want to edit something in this model, then click on edit. First, we have need to verify this model, is it running in software synchronization mode or not. It's not required. If you are using IOCAD, then it's mandated to use hardware synchronization mode. First, we have need to just verify it in software synchronization mode. Stop time should be infinite. It's a software synchronization mode. Okay, now in offline, this model is running. Then we have need to build it. In that building, it will take 2 to 3 minutes. Yeah, it's depend on your system, also depend on your model. So see here, it's generating your C code. Generating C code for master. If you get this type of error building SM ABC subsystem. Okay. Actually, it's not pinging. Just a minute. Now I turn on that simulator. It will take 2 to 3 minutes for pinging. XHP should be always on to reduce the jitter. Yeah, now it's connected with your simulator. We have need to build it again. Just a minute. Actually, this problem is coming due to I have connected with Wi-Fi. We are not recommending to connect with our OPAL Wi-Fi.
If clean file is we run it, it may come.
OPAL and your simulator IP address should be different, like 192.168. That 10 10.1.1. Yeah, now it's pinging.
शारीरिक नुकसान होता है।
Hello.
किसी भी चीज से हो सकता है।
Hello.
हाँ, एक्सेस
Hello. Yeah. No, that clean file, that error when it will come at loading stage. So it's the problem with that communication. So previously I was connected with Wi-Fi, so that problem was come with that Wi-Fi. So now I am connected with Ethernet. Yeah, now a model is built and we have need to load it before okay, first need to load it. At the time of loading, your console part will be open automatically. So whatever you want to change at the time of execution, you can change it here. So next is your execute. You didn't get exact sine wave result because some data loss communicating between your host PC to your target. And for this case, to reducing this data loss, we have need to increase that sampling time. After building, you have need to change this sampling time. Go to this probe control.
Sir, could you please magnify the image because someone is saying video is not visible.
Okay. Which video? My screen is not visible.
Yes, sir. Yes, sir. The screen is not visible to some of the participants.
So actually, we could see the screen. I think it is a problem from the participants' end. I think.
It's problem with all student, yeah, only for some participants.
No, sir. We can see your screen.
Okay, maybe it is the issue with internet connection.
Yeah. Sir, I suggest whatever the changes you are doing, just read out like 100 is changed to 1000, just read out so that they can understand it.
Okay, this one, no?
Yes, sir.
I think this one already open.
What are the changes you're making? Just read it, sir, so that it will be understood by others.
Okay, okay.
Okay. Okay. Thank you, sir.
After load your, after build your model, then you have need to go to this prop control. Okay. Then that maximum number of samples per signal, you can go up to 10 lakhs. Putting 5 lakhs. And number of samples per signal, same. Then apply. Again, load this model. Then execute it. This console part is not running as a real time. See, this is not is your real time. It's running as a simulating time. So your result is better than the previous one. So I want to zoom out this result. Yeah, now your result is coming. So I want to change this PWM, sorry, constant value 1, 2, 3. That means your amplitude should be 3, maximum should be 3. But here, yeah, Now your amplitude is free. Here is one feature. You can change it at online. This type is coming due to the data loss communication between your host PC and a real-time simulator. If you want to see this result in DSO, you can get it exactly same result. Okay, this is your software synchronization. Then we'll go forward for hardware synchronization more. And at that time, we'll use that OP write block, which it will be saved in your workspace. Then after that, we'll plot that graph. Okay, any question? Then we'll proceed for hardware synchronization more.
Sir, in the probe control, you have changed samples. Is it that
Yes.
only with respect to scope or the total
No,
system
only
sampling time?
only respect to that console part.
Console.
Okay.
Okay, sir. Thank you.
Okay, then we'll go forward for hardware synchronization more. Again, any question? Okay, then we'll go for hardware synchronization mode, and this is the main important. Same model, edit again. What we have need to change it? First, we have need to place here OP control block. It will be available in your RTLab IO. Then OPAL RT, then common, OP control block, and the second one we need to add this analog out. That means we want to see this result in DSO, and here DSO is not available. Same thing, I will take it loop back and I will see in O. This is your analog input. Okay. This
So
is
one
your
of the
analog
participant, sir, one of the participant is asking how to connect Ethernet.
Ethernet. Just a minute, I'll show you in phone. First, I need to connect with my mobile. After that, I'll show you. Prasan sir. Hello, Prasan sir.
Yes, sir. Tell me.
Please accept. Yeah. It's accepted. But here that camera option is not coming. Just a minute.
Sir, your screen is not visible.
Yeah, I stopped that screen. Now I'm connecting with my mobile. I want to show you how to connect that Ethernet cable. Okay, see my camera is visible now.
No, sir, not yet. No, it's visible.
Okay, just ping it. See, this is the backside of real-time simulator. Is it visible?
Mm,
No, sir.
somewhat blurry, sir.
No, sir, not visible.
Wait, I need to turn on my.
It's better you take pic and just insert into your slides, so it will be easy.
Oh,
for-
now it's visible.
It is somewhat okay. I think. What about other participants?
We could not see any video actually.
Yes, sir.
Okay.
Okay.
No video is visible.
Okay.
Do
Actually, in morning section, already I discussed how to connect this Ethernet from this port to your laptop. Again, I will show you in that picture. Okay.
Hmm.
Yeah, my screen is visible, no? Okay.
Yes, sir.
Okay, this is your backside of simulator, and this one is your Ethernet 0, yeah, Ethernet 1, and this one is your Ethernet 2, Ethernet 1. For Ethernet 0, your NC1 will be blink, and Ethernet 1, NC2 will be blink. So you can connect from here, yeah, here. For this Ethernet has two different IP address. If you connect here, then again you have need to connect your laptop Ethernet port. If you have not Ethernet port in laptop, you can use that USB to Ethernet converter. Okay.
Yes, sir. Okay.
Okay. This is your OP control block to operating our FPGA. Okay, we have need to using some code. So for this is our OP control block, and this is our analog output is connected in our output. Okay, and this is our analog input. Because here DSO is not available, I will loop back from analog out to analog in, and I will see in scope. So here is the input is 1. If you want to change it, that number of input is 2. Apply. Okay, this is your analog input. Whatever we take in analog in, we'll see in this DSO, sorry, scope. So for this thing, bitstream file is required. Here is one question, where is that bitstream file? How can we find that bitstream file? So for this, we have need to go system description. In system description, you will get your bitstream file like like this. For this system description, not for this simulator, let's say one university I am taking it for a demo, and like this your bitstream file mentioned in this. So where is the bitstream file available? First we have need to go C, then OPAL FPGA sim, then this version. I'm using this version common. This one, and here is your bitstream file, all bitstream file. Then how to know your board type? TE0741, yeah, BC707. How to know your board type? And for this case, you have need to right click on this. Actually, it's disconnected. When I will connect it, I will show you. And here is a one IO card info. At that time, you will get your bitstream file board type. So for here, that board type is TE0741, and for this one, that bitstream file is this one is our bitstream file. We have need to copy this bitstream file and paste it in our operative path. When you create your project, this is your operative path. You have need to paste it here. And here is your two file, one .conf file and another one is your .bin file. You have need to open .conf file. And just rename it, copy this name, paste in this. And board type is T0741. And always need to click disable strict hardware mismatch validation, apply. Okay, then we have need to mapping this analog output, analog input. Again, go to this file. Where is that analog output? For analog output, data input number is 21, not this one 23. This one is your data input number 21. Okay. This is your analog out. Data input number is 21. Before that, it's showing slot 0 module X subsection 0. After putting this value, apply, it's showing slot 2 B subsection 1. Then you can get it easily from your analog out. It will come from which module, which slot. And number of output channel is 1. If your signal is like 3, then you have need to number of A out channel is 3. And same for analog input. Data out port number is 3. This one. Now it's showing slot 2 module A subsection 1. And your number of input is 1. Okay. Now we have need to verify our model in offline. Is it running or not? Now it's running. Then now we are using our IO card. So this software synchronized mode should be hardware synchronized mode. After changing something in our model, we have need to build it. Sometimes, wait.
Sir, before building, can you add that option how to send the data to workspace so that we can plot in MATLAB?
No, after this I will tell you that OP right,
Okay.
no? Yeah. After that I will
Yes.
tell you. In same model I will tell you.
Okay. Sir.
Now our model is building. So for analog out, we'll get it from 2B. That means 2B. See, in your model, your analog out is 2B subsection 1. That means you will get it from 2B. Subsection 1 means 0 to 8. And your analog input is 2A subsection 1. That means you will get it from 2A. So for this, we have need to loop back. Actually, I am using this type of loopback cable. So I think in your institute, you have like FRC cable, white color loopback cable. So you can use that loopback cable. So now I am connecting loopback from 2B to 2A. This 2A to 2B. I'm connecting backside of real-time simulator. Also, you can use this screw terminal. Also, you can use this screw terminal. You can see your result in analog out, and you can take your result in your DSO. So now our model is built. Next is load our model. So now our model is loaded. Then execute it. Uh, it's a time really. So this is your analog input result. We'll take it from that loopback cable. Now I open this that loopback cable. Your result is 0. So again I connect this loopback cable. Okay. So I want to change this value. So that means amplitude 3. You can see that amplitude is changed. So I want to change it again 10. You can see that amplitude is 10. So for analog output, that maximum value is 16. If I will give maximum value is 20, suppose 18, what happen? We'll see above 16, it will be clipped. Above 16, it will be clipped. This is your one option to change this amplitude. And another one option, I want to change this sine wave frequency, then I have need to go this till our model sine SM. This sine wave, I want to change some parameter of this sine wave. I can change it from here. Now that frequency is 314. I want to change it to 628. See that frequency is changed. Again, I want to change it to 1200. 1200 means it will come approximately 200, 190 like that. See your frequency is changed. Now frequency is like 0, it will come DC signal. So this feature mean you can change at the time of execution. Whatever you want, you can change it at the time of execution. Suppose I want to change this frequency value like 500 radian per second. So I want to save it this value. Then you have need to click this one, save parameter. Yeah, it's permanently changed. Okay. And the next one is your here you can change that amplitude. You can edit your model block at the time of execution. That concept is that. Suppose you have PID control, you can change that PID value at the time of running, at the time of execution. So I have changed that amplitude. It's clipping because of there is a multiplication factor is 2, and here is your amplitude is 10. That's why it's clipping. Now it's come perfectly. Okay, this is your hardware synchronization mode, and it's the process of to use how to use that IO card, analog out, analog in, digital out, digital in. In same procedure, we'll use for digital out, digital in card. Okay, then next is your reset. Okay, now I want to see this result in .mat format. So I have need to edit in our model SM. Then we have need to OP write block. This block. Here is a calculation how to choose this value. There is a calculation part. I'll show you how to calculate it. Right click on your model block, go to help. You can see block description here, how to calculate that value. That buffer size should be like that, and a file size. So you can calculate here, but now I'm placing randomly. Again, we have need to build it after changes our model. Up to here, any question? Hello.
Hello?
Yeah.
Yes, sir.
Any doubt?
Any doubt from the participants? No, sir, no one. Kapil Sharma raised hand. Yes, Kapil. Kapil? Hello, Kapil? Okay, sir, there is no one to ask, so please continue.
Hello.
Hello.
Excuse me, sir. Can you please tell?
Yes, sir, your voice is coming. Just please ask the question.
Sir, my question is that sometimes it is showing error when
Okay.
the model
Error,
is.
error in that scope, na?
Yes, sir. Yes, sir.
Okay, actually, I told that thing that error causes of that communication between your host PC to your real-time simulator. We are using Ethernet cable. Okay, but there is some data loss. That's why that error is coming. If you want to see in DSO, you will get exact result.
And sometimes during building a model, sir,
Yeah, during building a model, error, no?
it also shows error.
No. This thing, no, this is not an error. This is a one type of warning. Just ignore this thing. Okay, if your building is successful completed, then you will see this load option. Otherwise, your load option like this type of disable. Okay.
Okay. Okay, sir.
Okay. Now, okay. Now model
Sir,
is
some more
built.
questions are there. Hello.
Okay. Yes.
How we got that amplitude, bias, frequency, and phase?
Okay.
One question.
How
Second
can we
question is,
change it? Okay. First I will
okay.
give answer that question. First, you have need to go to your model project, then model. Okay, click on this arrow of this model, then your model name, and after that SM subsection. Here is your block sine wave. Okay, you can change this amplitude, bias, frequency, and phase. Here, if you want to change your some modification in your block at the time of execution, you can change it here. Okay, next.
Next question is how to select opcom files from library. Please explain once again.
Okay, upcome block. Just okay. Go to library browser. Okay, RTLab. Here is your upcome block. Only one upcome block. It will depend on your subsystem name. If you will place in SC subsystem, it will show like acquisition 1, acquisition like that type of. If you will place in SM subsection, it will show like this type of sampling time. Only one upcome block. It will available in RTLab and here. And
Yes, sir,
it will
question.
always connected after your input, this input. Okay, see in master part, it's connected after input. Next.
Sir, can you show that upright block one more time?
OP right block, na?
OP right block, yes. Yeah, inside the model, sir. Inside the model, what things we have to do?
Simple. If you have two results, okay. Suppose if you have, I'm not changing this model because suppose if you have two results, okay, like 1, 2, you will give these two results. Just input that OP right block, and there is a calculation part how to choose this file size limit, number of samples per signal, buffer size in byte. I have taken it randomly, but you can calculate it according to this formula.
Okay, sir. Then no more questions there. So you can proceed.
Sir, I have one question, sir.
Yes.
Yeah, so here I heard talked about the sine waveform generation. We are changing the amplitude frequency by selecting the options, right?
Yeah.
Are we have any facility to change that frequency as an external parameter from other block lively, like frequency, amplitude?
Okay, that frequency, na?
Yeah.
I have changed here, na? This SM, this that we called optimization, that block, we can change it here, na, sine wave, that frequency, we have changed it to 500, like 1200, we have changed it.
So
Here,
I'm
na?
actually, this is configurable, like, by through parameters. Question is, for example, we have another block. Okay, there may be a multiplier block, and there is an output of that multiplier. If that output can be connected to this frequency, and the frequency can be changed on the fly while.
What's your model? Suppose, are you asking about some PWM generate? You can change that frequency from outside, no?
Yes, for this sine wave generation only.
Okay, sine wave, we can change that frequency some externally. We can change it from here. Then how can we change this model frequency from externally? Is it possible?
Do you have any control input, like changing frequency,
If they have any controller input, then we can change it easily.
Okay.
Okay.
So if the model is available in that way, then that can be changed easily, right? That's what you're saying.
Pardon?
So another question, right? Are we how the process is happening? Like, we are compiling the code. Is it going to generate the C code and dumping into the target hardware, or FPGA? So according to our this demo, we can see that it is building like a C code, right? The code
Yeah. So, but you want to see that actually C code, no?
Yes.
No, it's not possible to see that C code.
Okay, so but here we are generating the C code. If the number of blocks gets increased, can we able to meet the resolution or the sample time for all the blocks? How many number of blocks can support? For example, I need to generate different sine waves, 10 hertz, 50 hertz, 100 hertz, like that. I need to have different 10 sine wave blocks. So, is there any change of that speed and
sampling time? Fixed sampling time? Are you asking?
Yes, sir.
Okay, just wait. I will explain in next. Okay.
Sure.
Okay, now our model is built. Now we have need to load this one.
Sir, suppose if the system is very big, if you want to see all the system variables in the workspace, we have to use lot of operate blocks, or is there any other option?
System is very big. That means your system.
I mean, with a lot of components and other things.
Okay.
We have to use upright blocks for each signal separately, or without that, is there any alternate way to so that we can see all the system data on the workspace when it is running on real time?
Yeah, when it's running at real time, you can see all data like using this mocks now. This type of mocks. Suppose your signal is like 10, 14, you can use this type of mocks.
It means every system variable has to be given to upright file, or any other alternative method is there? That's my doubt, sir.
No. Only using that upright file.
Okay, so this data will be okay, sir. Anyhow, you are going to show now where it will be saved in the workspace. Okay, sir.
Okay. Now we go to this execute our model. Console part is automatically open. I want to change this value like 2. I want to see is it stored in copyright file or not, like 4, like again 1. Okay, we are changing some value, and you have need to, after reset you will got your that .mat file. Reset our model. where it will be available, we have need to go our sign one SM ABC, Red Hat, my file, and OPVAR. You can change your file name, like it's depend on your file name. Now here that file name is OPVAR and sorry, my file.mat, and variable name is OPVAR. You can change it to according to your preference. So next is your, this is your OP write file, and we have need to plot it. Actually, I have forgotten this code, how to plot this one. Anyone know? Please remind me how to plot. Otherwise, I have need to search in Google. Okay, this. Yeah, this is your sine wave. You can store this type and you can plot it like this. And this means this is your first row all column and the second row all column of OP bar. Okay, any question?
It is clear, sir. Thank you, sir.
Okay. And we'll take one break for after 10 minutes, we'll start it again. Hello.
Hello?
Yeah, we'll take one break after 10 minutes. We'll start it again and we'll see that inverter model.
Okay, sir. No problem.
Okay.
So we will start at 350 or
Yeah,
4?
350.
350.
Sir,
Okay.
sir, I have one doubt, sir, for
Yes,
the next
ask.
session.
Hmm.
Sir, suppose when we are running the inverter, let's say our sample time is generally we are taking 10 microsecond, 20 microsecond like that. If I want to run the model for less than 1 microsecond, maybe in the range of nanoseconds, please explain one.
No, it will
any
not
example
run.
for them, sir.
Yeah, it
Like
will not.
if we run in APGA using EHS block, I have seen one example model actually. But I could not understand it very clearly. That is the reason I'm asking.
Okay, where are you from? Your institute?
I am from NIT Rourkela.
Okay, is there EHS package?
Yes, sir.
Okay, from for EHS, we'll discuss on day after tomorrow how to use that EHS block. Okay.
Yes, sir. Yes, sir.
Actually, our CPU limit is 10 microsecond and 10 kilohertz. Okay. If you will run our model in FPGA, that limit is 200 nanosecond and switching frequency is 200 kilohertz. Okay.
Sir.
Okay. Okay, we'll start it 350. Yeah, 4.
So 355.
Okay, 355. It's okay.
Okay, sir.
Any questions? Someone asked. Okay.
So we will gather at 353. We will start 355. Okay, sir.
Okay.
Okay.
OPAL RT command. So this is your digital in block and this is your digital out block. Then and this is your PWM in. Here I will just explain it how to use this block. Same procedure for digital out, that we have need to mapping the data input number. This is our digital out. We have need to see here. Data input number is 22, 23, 24, 25. That means in digital card, total number of channel is 32. In each section, it's 8 channel. So if I will place 22, then your digital out, it will come slot 1, module B, subsection 4. So if I will place 25, it will come slot 1, module B, subsection 1. According to that, you can use 34 digital out. Suppose here in analog out, if you want to use channel number, particular channel number 3, how to use it? It's a simple concept. Use like mocks. Channel number 3. And connect one constant here. Now you will get your result in channel number 3. Here the number of payout channel is 3. You will get your result not in channel number 1. You will get it in channel number 3. Same in digital out. You can use it 8. So at a time you can use 32 channel. It's for 8. It's for 8. And this each block data input number should be different because it will coming in 1B subsection 1 and it will coming in 1B subsection 2. Same for digital in. For digital in, what the data in? Five, 4, 5, 6, 7, 8. 5. Then you will get your digital output from your slot 1 module A subsection 1. And you can take this digital out. You will given this is the digital in. Suppose in your hardware in loop model, then your inverter is it in your simulator, and you can generate some PWM from outside. You can give in slot 1 module A subsection 1, and you can validation your model in here in HIL mode. So at that time you use this block. So next is your PWM, and this is your PWM out. Suppose in your outside one buck converter, you want to generate pulse with modulation according to frequency and the duty. You just connect here one constant, the another one constant. Like switching frequency like 5 kilohertz, and your duty ratio is 0.5. According to that, your PWM will be generated. But it will generate in which port we have need to. Main thing is mapping. So PWM out. Load in 13. So that load in 16. So we'll get it 1B subsection 1. Data input number 16. Sorry, I have need to check it again. 13, 14, 15, 16. Yeah, this one. Data in number 25 for PWM. You will get in 1B subsection 1. Data in number 25. So this is your data in number 25. Then you will get PWM according to this. So here you have no need to design model for PWM generate. So you can generate it and you can give to your real inverter. Same for PWM input. Data input number suppose in 5. Then you will take it from plot 1 module A subsection 1. Okay. So in yeah, how to make hardware in loop? Main concept is this is your real-time simulator. Suppose inverter. Okay, that inverter output is voltage and current, and this is your controller. Will take this voltage and current as a controller signal, and your controller will generate PWM. Will give this PWM to your inverter. This is your real-time simulator, and this is your real controller. Okay, and I think you can use it for this. This is your analog output, and this is your digital in. You can use it, and you can validation your in hardware in loop. And the second one, how to use in RCP. In RCP, this is your controller, and this is your main model, real model, yeah, hardware. Suppose inverter. This inverter voltage and current will given to that controller. It will generate PWM and will give PWM to inverter. This is the real-time platform. So in this case, this real-time inverter, that voltage and current is high. We have need to step down this voltage and current. Our one product is OP8662. We can use this OP8662. In that OP8662, we can measure up to 600 volt and 25 ampere. We'll connect it here. Directly you can connect your inverter of voltage and current, and here you directly connect to your OPAL and you can control your inverter directly. Okay, any questions? Hello.
No questions, sir.
Then shall I conclude this 2-day session?
Okay, sir, we will conclude.
Okay, and next session we'll see how to implement real-time simulation in power electronics, how to implement real-time simulator in power system sector, how to implement real-time simulator in both power system and power electronics domain. So in next session we'll discuss about this e-phasor sim and e-mega sim and EHS and battery system management. How to BCS, battery cell simulator, will simulate in real time, and what the necessity of battery cell simulator and why we are using that battery cell simulator. Okay, and in next session we'll discuss about our microgrid model, how to control that microgrid model, what the concept of that microgrid model. Okay.
Hello, sir.
Yes. Tell.
Okay, Deva, something you want to ask? Otherwise, okay, we can end here, sir. Okay, someone asking.
And your how can I?
Hello, sir.
Yeah, ask.
Sir, in the inverter, you generate the only one pulse. If you want 6 pulses, you would, we connect the same digital output.
Okay. Your number of switch faults, how many?
I think the 6 three-phase inverter are.
Okay. Wait. Here, this is your digital out. Okay.
Yes,
You
sir.
can generate 8 number of in one section. Okay. If you use this section, then you can generate 16 up to 32 number of PWM. You can generate it.
Same blocks are connected. Otherwise,
No,
you
one
the-
block for only 8 channel.
okay. In that one channel, we connect all the six variables. Sir, enough.
Yes. For your case, PWM is 6 number of PWM, no?
Yes, sir. Yes, sir.
For this case, you can use only one number of one block. Here, number of D out is you have need to make it 6. Okay. Okay. Next question.
Is it completed? Shall I ask some more question?
Yes.
So one question is, could you please explain difference between SIL, HIL, and RCP in detail?
Wait. Again, I'll go to that slide. This one. Okay. In this, first is your modeling loop, MIL. Okay. In modeling loop, your plant and your controller both are in simulator. Okay. And second one, your RCP. In this case, your plant is real. Suppose your inverter is real, but you are generating PWM from real-time simulator. So it's behave like as a controller. So in this case, we call rapid control prototyping. And this is your hardware in loop. This case, your controller is real, but your inverter is simulated. That means your inverter in simulated means controller output is PWM, and this inverter control input is PWM. That means you can use that digital in card and you will give this PWM to your plant. So that's we called hardware in loop. Okay. Another one is your power hardware in loop. In your analog output, maximum output voltage is plus minus 16. So that's why we are using power amplifier. This case, your grid is it in simulated, but we can interface your simulated grid with a real microgrid using this power amplifier. That's we call power hardware in loop. Okay.
Okay, sir. Next question is how to find power rating of OPAL RT.
It's power rating means OPAL RT power rating that IO card rating.
Only 15 volt or something, na?
Yes, that analog output maximum is 16 volt. Analog input maximum is plus minus 20 volt.
We have to map with respect to that one.
Yes.
One more question is there, sir. Maximum sampling type of time of OPAL RT in fixed type.
Yes. Oh, in fixed type, it's always running in fixed type solver. That maximum sampling time, you can go up to millisecond, 1000 millisecond, no issue. But we are always recommending to run our model in minimum sampling time to accuracy our model. So accurate result, we are going for lower sampling time. Okay.
Okay, sir. One of the participant is asking about hardware configuration manual. Could you please share it?
Hardware configuration manual means
Manual.
this one. This one.
Mhm.
This one system description, yeah, somewhat. I'll share this 3 PPT. Okay.
Okay, sir. Okay. So,
But for this system description, it's depend on the client ID. It's a different configuration for different client. Okay.
okay. So, participant said model number is 5600.
Model number? It's not depend on.
5600.
Yeah, it's not depend on model number. It's depend on project number.
Okay. Okay, sir.
So according to that project number, I'll share it with him.
And for the models or any kind of manuals, they can contact the OPAL site and customers from sales.
Yes, yes. To
Yes, they
contact
provide.
technical support. You maybe contact with me. This is my mail ID. Yeah, you can contact with me. This is my mail ID.
Okay, so hereafter all the question has been answered.
Okay, thank you, sir. Thank you for giving 2 long sessions to us. I hope that participants got some basics of the OPAL and they can carry forward their research work in using the OPAL if anyone wants. And then any other queries if any participants are having, they can ask in the next session also. No issue, because we will be conducting the OPAL in 2 sessions on Friday. And
Day after tomorrow.
Day after tomorrow, we will be having 2 sessions on OPAL. So if anyone having any doubt, they can ask on that day also. Okay, Nirasa, thank you. And we can.
Okay, sir. Welcome,
sir. And participants, tomorrow there will be 2 stations that had been scheduled before for day 3. That will be Rajan sir and Tanmay sir will take 2 sessions on solar pump and bidirectional DC to DC converter. And we'll meet at 10 AM tomorrow. Thank you.
Okay, sir. We'll meet a day after tomorrow.
Yes, sir. Yes, sir.
Sure, we will be waiting.